Hello everyone, welcome to Com Planner Studies, your student's guide. And if you are new, don't forget to like, share, and subscribe. Recommend this channel for your friends who are struggling with courses like digital logic design, for instance. So let's delve into today's topic. We'll be looking at logic operators, lesson 4. So let's get started. So before we really talk about logic operators, let's look at constants and variables. So what is a constant? A constant in logical expressions, constants represent fixed Boolean values, usually true high, that's 1, or false low, which is 0. They stay the same throughout the expression, so a constant is always fixed. We understand that a constant has a fixed value. So we see 1 and we also see 0. 1 represents high or true, and 0 represents low or false. So variables are symbols that can take on the values true, 1, or false, 0, and they can change depending on them. Variables can actually change, they are not fixed. They are different from constants because they can actually change. So a variable can actually change. It's not a fixed value. A variable is not fixed. And just for an illustration, a variable can take on a capital letter, for instance, can represent a variable. And that variable can take on values like 1 or 0. So that means A can take on 1 or A can take on 0 because it's not a fixed value. It can change. So not only A, any letter of the alphabet can be used to represent a variable like X, like Y. So that's what a variable is. So now that we understand what a constant is and what a variable is, we can go into logical operators. So we talk about the OR operator. It's used for logical addition. We'll see why it's used for logical addition. So what does the OR operator do? It gives an output of 1 if any input is 1. It gives an output of 1 if any input is 1. And if none of the inputs is 1, it will give an output of 0. Its symbol is the plus sign. The plus sign. So let's get right into that. We see an illustration. If we have 1 or, this is the plus there represents or, logic or. So 1 or 0, 1 or 0 is 1, 0 or 1 is 1. In these two cases, we have one of the inputs as 1. So 1 or 0, 1, 0 or 1, 1. For instance, I say it is Monday or it will rain today. It is Monday or it will rain today. So if it is Monday, then what I said is true. Or if it rained today, what I said is also true. So true or false is true, and false or true is also true. So far as something I say is true, because I said or, I said it could be any of the two cases. So if anything I say is true, then the result is true. So same goes for 1 or 1, it's 1, because both of the things I said, or both inputs are true, so the output is true. And 0 or 0, that's false, because my two inputs are false. My two inputs are false. This is false, and this is also false. So of course, my result is false. So one of your inputs must be true. At least one must be true for you to get an output of 1, an output of true. For you to get an output of T, true. And if none of your inputs is 1, then you get an output of false. So that's the concept there. That's the concept. And we're ready to go into the logical AND operator. The AND operator is also called the logical product. The logical product. Because it gives an output of 1 if both inputs are 1. So both of your inputs here have to be 1. You're saying and. So this and this. That means both of them must hold true before you get an output of true. If not, you get an output of false. So if not, it gives 0. Its symbol is a dot. The dot is used for product. So yeah, its symbol is a dot. So let's take a look at that. For instance, I have two variables, B and C. I've got B and C here. The dot, as we said, represents AND, logical AND. So I've got B and C. And if B takes on 0 and C takes on 1, that B takes on false and C takes on true. False and true. It will rain and today is Monday. It will rain, let's say it doesn't rain and today is Monday. I said it will rain and it is Monday. So although today is Monday, although C is true, B is false. B is false. It's not Monday. So false and true would definitely be false because I said and, so both have to be true. So that's the concept here. So 1 and 0, 1 and 0, it's still 0, false. So we've been getting answers of false because we're using and. 0 and 0, false and false. False and false is false. So you'll get a false. But when it's true and true, T and T, true and true, we'll get an output of 1, and that is true. So it's very simple. You get an output of 1. So if you notice, 0 and 1 is 0. 0 and 1 is 0. It's like 0 times 1, which is 0. 0 times 1 is 0. 1 times 0 is 0. 0 times 0 is 0. And 1 times 1 is 1. So it's like product. It's like a logical product. Multiplying these two will give you your answers. Then if you come over to OR, if we take a look at OR, we called OR logical addition. Logical addition. Because 1 or 0 is 1. It's like saying 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 1 is 1. 0 or 1 is 1. So that just gives you it. That you take a look at this. 1 plus 1 is actually 2. So 2 is a high signal. 2, the number 2 is a high signal. It's high signal. It's high. It's not 0. It's higher than 0. So it's a high logic state. It's a high state. And since it's a high state, that still counts as true. So 1. And 0 plus 0 we know to be 0. 0 or 0 is 0. So there you have it. That's why we call OR logical addition and logical product. It will come in handy. So let's continue. We go to the NOT operator, or as it is so called, an inverter. An inverter. Why is it called an inverter? Because it changes the input from 1 to 0 or from 0 to 1. From 1 to 0 or 0 to 1. So it's going to change your input. It only has one input, unlike AND and OR that had two inputs. This one only has one input, and it will change the value of that input from 1. If it's 1, it's going to change to 0. And if it is 0, it's going to change to 1. So this is called negation or complement. Negation or complement. Its symbol is a dash. Should I say a one like to power one. Just a stroke at the top of the variable towards the right hand side, the top right hand side of the variable. Let's see that practically on paper. Let's try and see that on paper. So I have a variable x, right? I have a variable x. A variable can take on any value, 0 or 1, as you had already established. So I have a variable x, and that variable is set to 0, false. Now, x complement, look at that, it's like a 1, the number 1 written at the top right corner. This represents negation, complement. So x complement is equal to 1. The negation of x is 1. Y. Y is another variable, and y takes on the value 1. So y complement is 0, false. So it changes from true to false, or from false to true. Very easy. So moving on in discussion, we cover the last logical operator, the exclusive OR operator. So we want to cover exclusive OR. So exclusive OR, and we see that exclusive OR gives an output of 1 if the total number of ones in the input is odd. So the total number of ones in your input has to be 1. Has to be odd rather. It has to be an odd number. And if you have an even number of ones, you'll get an output of 0. Its symbol is it's a plus enclosed in a circle, like enclosing a plus in a circle. That's the symbol for exclusive OR. And just a note there, A exclusive OR B is equal to A complement and B, or A complement and B, or A complement. So that's what A exclusive OR B is. We'll also see how this is. We'll actually prove this. So let's dive right in. So we actually said that that in exclusive OR, to get the output, the total number of ones in the input has to be odd. So if I have 1 exclusive OR 0, 1 exclusive OR 0, there's only one in the we have two inputs, input 1 and input 2. So there's only one in the input. There's 1 and 1 is an odd number. We have the odd numbers. These are all odd numbers. We've got the odd numbers as 1, 3, 5, and 7. So as in, if you have one true value, then your output will be 1. If you have three true values, your output will be 1. If you have 5 true values, your output will be 1. So if you have an odd number of true values in your input, then your output will be 1. So in this case, you only have 1, and the output is 1, true. So let's consider some possible scenarios here, some possible cases using variables. So A exclusive OR B, 1 exclusive OR 1. I've got 2 true values, 1 true value, 2 true values. So that's even. Even numbers are 2, 4, 6, 8, 10. We call these the even numbers. These are all even. We call these even numbers, and if you have 2 true values in your input set, then you're going to get a false as your output. Here I have 0 exclusive OR. This is the exclusive OR symbol, XOR, as we call it, exclusive OR. And what's the output here? 0 exclusive OR 1. We only have one true value. One value is true. So 1 is odd, meaning that my answer is true. And here we have no value. That's true. So 0 is not an odd number, and 0 is not an even number, right? 0 is not odd, 0 is not even. So it still falls under not being odd, because that's the condition. It must be odd, an odd number of true values, an odd number of true values. If it's even, it gives you 0, or if you have nothing, no odd value, that you have nothing, no true values, it will still give you 0. So that's why our output here is false. So just to prove our little statement that we had, the statement we made that A exclusive or B is equal to A complement and B, or A and B complement. To prove that, let's consider this example. This is the formula here. This is the formula, and let's assume in this scenario that A is equal to 1 and B is equal to 1. So let's test A exclusive or B, or 1 exclusive or 1. Let's test it. This will be 1 complement and 1, or 1 complement and 1, or 1 complement and 1. So A complement and B, or B complement and A. It's as easy as that. So 1 complement is 0. Remember, the complement switches 1 to 0. So we have 0 and 1, or the complement switches 1 to 0. Okay, 0 and 1, or 0 and 1. So 0 and 1, true, false or and true is false, and false and true is false. So false or false is false. False or false is false. So it means that we see that this 1 exclusive or 1 is equal to 0. And remember, we said that when there is an even number of true values, your output will be false, and this proves it. So this is the formula for exclusive OR in terms of and, or, and the complement or negation. So with this, we have come to the end of the lesson. Hope you understand everything. As usual, if you have any questions concerning this lesson, this lecture, you can always drop your comments at the comment section below. Don't forget to like, share, and subscribe. Recommend this video for your friends, recommend it for your classmates, and have a nice day.